do something briefly on composite functions. But for you to understand composite function, you need to understand evaluation of a function. Now, I've written on the screen the definition or the basic information that you need to know about evaluation of a function. Evaluation of a function involves replacing the value of x, which is an independent variable, by a suggested value. The suggested value is being given maybe in the question, or sometimes you may be needed to choose maybe an arbitrary value, but mostly you will be needed. Now, what is an independent variable? If you haven't seen our previous recording, please go and check it. There we have explained briefly and deeply. Briefly it means it is not long. Deeply it means it is into details. The difference between different types of variable, the independent and the dependent variable, and how each are correlated to each other. So from there you can easily understand that. So now I'm saying evaluation of function involves replacing the value of x in the independent variable by the suggested value. Now let's look at an example. For example, let's pick an example, like for example we have y of sorry for that, y of x, for example, is equivalent to 2x plus 6. I'm writing an example directly in my screen so that you can see that these things are not hard to be done. So now when you have been told, given that let me add here, given that y of x is equal to 2x plus 6, comma, determine. So you might be told determine, let's start with the first one, y of 0. You may also be told to determine, let's look at another one, y of negative 1. You may also be needed to determine, for example, y of x plus 2. And also you may be needed also determine, for example, y of a. Now all these are not difficult to do. Now starting from the first one, you have been told determine y of 0. Y of 0 means you are going to take 0 and substitute as x in the given function. That is, you have a function y of x. You have the function y of x is equivalent to 2x plus 6. Now what we are saying that in case you want to get y of 0, then basically what you are going to do here is take 2 and then instead of x put 0 and then add the constant that we already have there, 6. And this is going to be giving you 2 into 0 is 0, so plus 6, that gives you 6. Now in case they want now for you to get y of negative 1, this is also simple. What you need to do is take the value of negative 1, substitute as your x in the function, so it is going to be negative 1 there, and then add 6. So this is just like 2 times negative 1 is negative 2 plus 6. Negative 2 plus 6. Negative 2 plus 6 is 4. Now let's look at the last one first. Y into bracket, or let's say y of a. It is called y of a. This means you just need to substitute whatever we have there as x as a. So instead of putting x, we are going to substitute it with a. So plus 6 and that is going to be giving us 2a plus 6. As simple as such. Now let's look at the last one there. Y of x plus 1. Now this means that instead of putting x in the function that you have there, we are going to be putting x plus it is x plus 2. Instead of putting x there, we are going to replace it with x plus 2. Let's see. So that is going to be 2 into, instead of x, it equals x plus 2. X plus 2. And there we are going to be adding, of course, 6. Now you need to simplify. This is going to be 2x plus 2, then plus 6. And that can be simplified further into 2x plus 8. I want you to master the last concept that I've just said. Y of x plus 2. It is going to help us later in the calculation or evaluation of composite function. Y of x plus 2. We need to take x plus 2. Substitute, instead of putting x in the function of y, you put x plus 2 in a bracket. The bracket is important to prevent any manipulation of the result that is going to be giving you erroneous values. We need the right values. So I think I this is x plus 10, so that is going to be 4. Now, as simple as such, you just need to be cautious and ensure you do the right thing. That's all about evaluation of a function. Now let's move now into composite function. Now from the screen you can see composite function is a function whose value is obtained by substituting another function into it. I'm going to be doing examples so that you can see this. This also might be challenging, but it is not that much challenging in the moment you understand the concept. Now, most of the composite functions have specific ways at which they are always being called. Mostly they are being called f of something, and both of the two are a function. For example, let me pick an example just after definition there. Now you might come along and meet something like f of g. F of g. O is of, f is a function, g is also another function. So f of g of x. This is a composite function because f is a function and g is a function, and this function is being formed by conjoining f and g in a specific way. You might also understand, or I might make you to understand that f of g can be written as f of means hiyo chenye inafuata iko ndani. The thing that is following there is inside a bracket, so it is f of g inside the bracket. Then g is also followed by bracket of x, so you also put that in the bracket. So this is read as f of g of x. F of g of x, the same as f of g x. Both of the two are read in the same manner. So what I'm saying is that for you to find f of g of x, you are supposed to substitute the value of x in the function f. Value of x in the function f is substituted by the whole function g. You'll be able to see that in an example briefly. Value of x in the function f is substituted by the whole function g. The same way in the previous example we did substitute, rather than writing x, we substituted it with x plus 2. So we will be substituting the whole function g as the value of x in the function of f. Now let's look at an example to make the work easier. So now given, I'm not choosing very hard things, I'm just writing them so that you can see that they're not that hard to do. Given f of x is equivalent to 6 minus 2x. Also, let's add another thing. G of x is equivalent to g of x is equivalent to 1 plus 5x. Then our question now come. Determine the first part, f of g of x. The second part, g of f of x. The third part, f of g of 1. The fourth part, f of g of f of 0. Now let's start with the first one, f of g of x. Now I've said for you to determine the value of f of g of x, it means you take g is in the bracket. From what you can see here, you can see here g is a bracket of f, so it means anywhere you have x, you are going to substitute by the function with the function of g. So now for example, f of g, take the function f. Our f is 6 minus 2x, but now because we want to substitute this our x, it means rather than writing this x here, we are going to replace it with the g as a whole, the whole function g. If g had a denominator or something, or a power or something, you take the whole function the way it is and then substitute it there. So it means we are supposed to be having 6 minus 2. Rather than writing x, we are going to write, rather than writing this x, we are going to be writing 1 plus 5x. 1 plus 5x. That is going to be giving us f of g of x. 6 minus 2 into bracket. I prefer use of bracket because that prevents manipulation. This cannot give you the same result if you don't put a bracket. Negative 2 will only multiply 1 and won't multiply 5x. So f of g, so at the end you are going to be having 6 minus 2 minus 10x when you open the bracket, and this is going to be ending at 6 minus 2 is 4, so 4 minus 10x. That is the function f of g of x. Now there is this one where you are being told determine f of g of 1. We have already gotten f of g of x, so it means in the function f of g of x that we already have, substitute x with 1. So it means in case you want f of g of 1, then in the function what we already have here is 4 minus 10x. So in this function, rather than putting x, substitute it with 1. So it means I prefer use of bracket. It is useful. It is going to help you avoid error due to charges and those signs. So 4 minus 10, that is going to be minus 6. The next one, g of f of x. Similarly, we have g of f. It means f is inside g. I've said this can be written as g into bracket f into bracket x. So it means f is inside g. So take g, rather than putting x, substitute the function of f inside x. So this is going to be equivalent to 1 plus 5x. That is our g. But now, rather than putting x, I'm going to substitute it with f, 6 minus 2x. So that is going to be giving us g of f of x, and that is going to be equivalent to 1, that is plus 30, and that is minus 10x. So when you solve that out, it is going to be 31 minus 10x. Now there is this part that says, now it is not part of that, of this, but now what if you have been told to find g of f of 4, for example? So g of f of 4 is the same as substituting 4 instead of x in the g of f. It means in case you've been told find g of f of 4 without being told to find g of f of x, you must first get g of f of x as your first step. So this is supposed to be, because we already have our g of f of x, then we're just going to substitute it by 4, the x that we have there by 4. So put there 4, and that is going to be given as 31 minus 14, and that is minus 9. Now the last one, g of it is f of g of f of 0. Now I'm still saying and I'm still repeating, you cannot get f of g of f of 0 without first getting f of g of f of x. So first thing that you must get here is f of g of f of x, and that is going to be equivalent to, break this into parts. The first part, you start from the innermost, ukienda nje. You start from the innermost going outside. So the first part is g of f. So take f, substitute in g. What is our g? So let me put here step 1. Step 1, I've said what you need to do is break that thing into parts. Break into smaller parts. And now after breaking, we are finding that you start from the innermost. So the first one in the innermost is g of f. So g of f, of course, of x is going to be equivalent to, so take f, substitute in g. What is our g? G is 1 plus 5x. So rather than writing x, we are going to substitute it with f, and our f is, use bracket, 6 minus 2x. So that is it. So when you solve this, which we already did here, g of f, we already did that here, it's going to be giving you 31 minus 10x. Then the last part is now, the second step, step 2, to make your work easier, categorize already evaluated part as a whole and evaluate the remaining part. Now this is what I mean. G of f of x we already have, but now what we want is f of g of f. So I'm saying take it as a whole. So f of g of f as a whole, which we already have. So this is f of what we have up here, f of g of f. G of f is what we have here, so it is f of what we have here. And what is our f? Our f, if we check here, let me take you back briefly. If we check here, our f is 6 minus 2x. So we are going to put here 6 minus 2x. But now instead of writing x, we are going to substitute it with the g of x, what I've just put in the bracket. So when you substitute that with g of x, it means rather than putting x, I'm going to put my bracket, of course, as usual. Put 31 minus 10x. Now what I'll be getting here will now be f of g of f of x. Of course, there is an x here, so so there is an x there. So ensure you use bracket to avoid complication. So this can be simplified into 6 minus 2 multiplied by 31 is 62. Then plus negative times negative is positive, so plus 20x. And now this can be further simplified into, that is 20x minus 62. 6 minus 62 is going to be giving you 56. Now what we have just gotten there, this is f of g of f of x. But now the question doesn't want that. Our question need f of g of f of 1. So it means what you are going to do here is to substitute x in f of g of x with 1. So we have it as 20x minus 56. Substitute x here with 1. Ensure you use bracket. No, it was 0 actually, I'm sorry. I think it was 0. It was 0. Yeah. If I check here, it is supposed to be 0. So now rather than putting there x, I'm going to be putting my 0. Then now that is going to affect my answer, and my answer is going to be negative 56, because 20 times 0 is 0, then minus 56, that gives you negative 56. That's how you solve any composite function. You can even be given, let me write here as an exercise in caps. You can even be given maybe like f of g of f of g of this one. The same question that you have there, you can attempt this of 3, for example. So it means you are going to break this into parts. The first part is going to be f of g. The first thing that you always do is finding the one for x and not 3. So you are going to get f of g of x. Group f of g of x as a unit and then solve g of that whole unit. So group the whole as a unit. So it means, here's step 1. Let me give you a hint. Step 1. Solve f of g of x, and that we have gotten from the innermost. The innermost is this one. Sorry. The innermost is this one. Starting from here. Starting from there up to here. My laptop is misbehaving. Now starting from where this f of where 3 is starting up to this point where we have f. So starting from g o f, that is the innermost. Then now I'm saying you have solved that. Step 2. Group it as a unit and solve f of no, the second part here is G here, G of f of G. F of G you have already gotten and you have grouped it. So you are solving G of whatever you have grouped, f of G. And of course it is of f of X. So there you are going to be getting your first, another part. And then the step 3, which is the last one, group the already solved and complete evaluation. The evaluation. Now I've said this can be written as without the bracket G of f of G of X. So now we are saying you are now grouping this as a unit, this G of f of G as a unit, substituting it into f. So if you have your f and you have already gotten G of f of G, substitute your answer in f. So that is going to be giving you f into bracket G of f of G. Of course it is in terms of X. And we are saying this is the same as let me put off here. Of course I'm not supposed to put off and as well as bracket at the same time, but I'm using that for explanation purposes. F of G of f of G of X. Now you have gotten your f of G of f of G of X. Now from there, in the answer that you have, substitute 3 instead of X. So the last step, step 4, substitute X with 3 in the answer obtained in step 3 to get f of G of f of G of 3. Now that's how it is done, not complicated. Now thank you for giving us your time and your peace so that you can be able to understand briefly something about composite function. If you have any question about composite function, feel free, just comment in the comment section. I'll be able to do it and also consider it in my next video. Now please take your time, click the subscribe button and comment so that we can know whether this information that we are giving is actually helping somebody somewhere. Thank you for your time and have a blessed day.